Assalamualaikum and good day to everyone. Today we'll continue with chapter 9, multi-stage amplifier. Okay, as we mentioned in the previous slide or previous video, there will be 2 or more stages in a multi-stage amplifier configuration. But in this example, we have 2 stages only, where both stages are identical, CE, amplifier, with the output of the first stage is capacitively coupled to the input of the second stage. Okay, so this is the first stage and this is the second stage. Okay, and this capacitive coupling actually prevent the DC bias of one stage from affecting another stage. So in determining the voltage gain of the first stage, we must consider the leading effect of the second stage. Okay, so now as the C3 here appears as a short at the signal frequency, so the total input resistance of the second stage presents an AC load to the first stage. Okay, in other words, if you are looking from Q1 here, so R5 and R6 will be parallel with R3 and R in base. Okay, so we can redraw this circuit into this AC equivalent circuit. Okay, where R3 parallel with R5 parallel with R6 and R in base 2. Okay, so this is actually input resistance of the second stage. Okay, now let's do the DC analysis of this multi-stage amplifier. Okay, so for the VB, it is given by R2 over R1 plus R2 times VCC. So we will get 10K over 47K plus 10K times 10 volt. VCC, this is VCC, 10 volt. Okay, so for VB, we will get 1.75 volt. Okay, after we get VB, we can calculate VE. So VE is equal to VB minus 0.7 volt. So VE equal to 1.05 volt. Next, we can calculate IE, where IE is given by VE over RE1. Okay, RE1 or R4 here. So equal to 1.05 over 1K. So equal to 1.05 milliamps. Okay, so now we know that IC is equivalent to IE equal to 1.05 milliamps. So now we can calculate for VC, where VC is given by VCC minus IC RC, or in this example RC is R3, right? So this is R3. So 10 volt minus 1.05 milliamps times 4.7 kilo ohm. So finally VC is equal to 5.065 volt. Okay. Okay, now we need to do the AC analysis of this multi-stage amplifier. So here we already have an AC equivalent circuit. Okay, so to determine the voltage gain, we need to calculate the RC1, where RC1 is given by R3 parallel with R5 parallel with R6 and parallel with R in base. Okay, and then this R in base 2 is given by beta AC times RE prime plus RE1. Okay, so now we need to calculate RE prime. So RE prime equal to 25 millivolt over IE. We already calculate IE before this, so we will get 25 millivolt over IE is 1.05 milliamp. So RE prime equal to 23.81 ohm. Okay, so now we can calculate R in base if beta AC is given by 150. So beta AC 150 times 28.81, but RE here is 0 since the capacitor here is open. Okay, so R in base equal to 3.57 kilo ohm. Okay, so now we need to calculate RC1. So RC1 is 4.7K parallel with 47K parallel with 10K parallel with 3.57K. So after solving this, we will get 1.63 kilo ohm. Okay, so now we can calculate the base to collector voltage gain of the first stage. So AV1 equal to RC1 over RE prime. So 1.63 K over 23.8 equal to 68.49. So this is the voltage gain of the first stage. Okay, next for the second stage is given by AV2 over R7 over RE prime. Okay, so why R7? Because there is no load resistor at the second stage. So we just take it, we just use R7. So 4.7K over 23.8. So finally AV2 is equal to 197.48. Okay, so for the overall voltage gain it is given by AV prime equal to AV1 times AV2. So we will get 68.49 times 197.48. So we will get 13,525. So this is the overall voltage gain. Okay, so if we convert it into dB, we will get 82.6 dB. Okay, so that's all for the capacitively coupled multi-stage amplifier. Thank you.